Welcome to class. I hope you are doing good. Today, we shall be looking at the topic redox reaction. We shall be exploring the concept, the fundamental concept of this topic. When it comes to redox reaction, there are a lot of definitions given by some scholars who have actually worked on this topic. Redox, as you can see, R-E-D-O-X, is a combination of reduction and oxidation reaction. The R-E-D simply means the reduction reaction, while the OX means oxidation reaction. By the end of this class, we shall be able to explain what oxidation reaction is and what reduction reaction is. We shall be able to calculate oxidation number of elements in the neutral state and elements in their combined form. I want to begin by defining the first definition given under this topic. I will take it one after the other. I will take oxidation reaction first. After oxidation reaction, I will be discussing redox reaction. The first definition, it was defined in terms of electron transfer. Oxidation is defined as a reaction involving loss of electron, a reaction in which electron is lost. A situation where iron 2 chloride moved to iron 3 chloride. Iron 2 chloride moving to iron 3 chloride. If iron 2 chloride moved to iron 3 because it actually reacted with an element chlorine to give iron 3 chloride. Now let us specifically focus on the element, the metal, which is iron. Oxidation number of iron here is 2. Then moving to iron 3, that is what? An increase in oxidation number. And what happened during increase in oxidation number is that there is loss of electron. How do you ascertain this? How do you find out this? How do you discover this? Look at that reaction. The oxidation number here is 2, plus 2, and here is plus 3. What do you do to balance this ionic equation? You introduce electron. What does electron do to ionic equation? Electron reduces the charge, the positive charge, in order to balance the equation to the other side. Now, looking at two of them, you can ascertain that the oxidation number of plus 3 is more than that of the plus 2. What happens? In the course of balancing this equation, an electron is actually added. An electron is added. How many electrons will I add here to equate it? That is 1 electron. Because an electron introduces a negative value when redox equation is being balanced. Now, when you watch this, if we should calculate and check it both sides, we have plus 2 here, and we have total of plus 3 minus 1. And that equates to what? Plus 2. If you make your observation, you will find out that because of the introduction of the electron at the right-hand side, both sides now is balanced by plus 2 plus 2. What happened? This substance called iron 2 lost electron. Look at the arrow. Watch it. It lost an electron. That is the first definition, or one of the definitions of oxidation. Loss of electron. Loss of electron. Redox reaction, if you watch on the screen, you see that redox reaction involves the transfer of electron between chemical species. With what I have on the board, it moved from ion 2 to ion 3. And in cause of that, an electron is being lost. Okay, that is the first definition. The next definition of oxidation is a reaction involving addition of oxygen. A reaction involving addition of oxygen. A reaction involving addition of oxygen. This addition of oxygen mostly happens when there is combustion reaction. But even at that, even without combustion reaction, any reaction in which oxygen is involved, oxygen is added during the process, that is oxidation reaction. To throw more light to this, I want us to make a very good observation here. You will observe that when copper 2 oxide reacts with hydrogen to produce water and the copper. Watch that reaction very well. Watch it. What did you observe? Take your time. Let's move the reaction from copper 2 oxide. Now let's go. Let's move it from copper 2 oxide. Oh, okay. Let me start it from here. Sorry. Let's move it from hydrogen. A reaction started from hydrogen and landed in the water. From the reactant side to the product side, you will discover something. The reaction started with only hydrogen as an element, or as a chemical. And at the end of that reaction, you can observe that there is oxygen added into the original hydrogen where the reaction started with. That shows there is addition of what? Oxygen. Here, from here to here, there is addition of oxygen. So here we have addition of oxygen. Addition of oxygen. That means oxidation reaction has taken place here. Wherever oxidation reaction takes place, there must be an oxidizing agent. What is oxidizing agent? The particular reactive element or compound which reacted with the hydrogen, which is copper 2 oxide. Copper 2 oxide. Okay? That is the second definition of oxidation reaction. A reaction where there is addition of what? Oxygen. This is experienced when combustion reaction takes place. A situation where magnesium bonds in oxygen, magnesium Mg bonds in oxygen to give magnesium oxide. Magnesium oxide. Magnesium oxide. What have you observed? A situation where reaction started from magnesium and they landed to what? Magnesium oxide. Can you see what happened? It's a combustion reaction, but it involves addition of oxygen. There is addition of oxygen to magnesium. That means from magnesium to magnesium oxide is addition of oxygen. Addition of oxygen. That means what actually took place there is what? Oxidation reaction. Oxidation reaction. So what do you think could be the oxidizing agent? Taken from the previous example we gave, okay? The reactive element there, which reacted with magnesium that led to the formation of magnesium oxide, invariably is oxygen. That shows that in that reaction, oxygen is the oxidizing agent. In every oxidation reaction, there must be what? Oxidizing agent. And in every reduction reaction, there must be reducing agent. For now, we are taking time to explain all the definitions, giving all the explanations that can help us understand what oxidation reaction is. The first we have taken is loss of electron. A species that loses electron. The second one now is a reaction where oxygen is added. A reaction where there is oxygen involvement, be it through combustion, be it through ordinary substance that's very reactive, reacting when it's exposed to the atmosphere, interacting chemically with atmospheric oxygen, because there are very reactive elements that when kept open, they actually react. Something like sodium and potassium are very reactive metals. They can as well react with oxygen to produce oxide of the metal. Whenever a reaction is taking place, and from the equation, you notice that there is addition or involvement of oxygen, oxidation has occurred. That is the second way we can understand oxidation reaction. The third definition that can help us to understand this concept is a reaction involving removal of hydrogen. Removal of hydrogen. A reaction involving removal of hydrogen. Now, a reaction involving removal of hydrogen. Let's look at this. Take a look at hydrogen sulfide is reacting with chlorine. That gives me hydrogen chloride plus sulfur. Plus sulfur. Look at that reaction. Look at that reaction. A reaction involving removal of hydrogen. Permit me to start this reaction with hydrogen sulfide. And let me move to the product side. As I move to the product side, I will drop it at where sulfur is being deposited. What can you see? Chemical reaction has taken place, but hydrogen has been removed. Originally, the substance called hydrogen sulfide contains hydrogen and the sulfur. At the end of the reaction, looking at the product side, you can only see sulfur. What happened? There is removal of what? Hydrogen. That means oxidation has taken place. Removal of hydrogen is another concept, another pattern, another way you can understand oxidation reaction. That means the reactive metal that actually reacted with hydrogen sulfide at the reactant side is chlorine, which shows that the chlorine here is the oxidizing agent. I told you at the beginning that in every oxidation reaction, there must be an agent, there must be a substance that is responsible for it. And that is substance that actually reacted with the other one. Okay, this is removal of hydrogen, which is oxidation reaction. That's number 3 concept. We'll move further to explain oxidation reaction using increase in oxidation number. Increase in oxidation number. Increase in oxidation number, most teachers or most scholars join it along or carry it along with that of the loss of electron. Because where there is increase in oxidation number, there is loss of electron. Wherever you see the oxidation number of a species, of an element, of a compound increasing, watch it. Calculate the oxidation number. Whenever there is increase in oxidation number, watch that species is actually losing electron. So oftentimes you don't look at two of them as different concepts, but in order to make the explanation much clearer and explain it better, we'll try to distinguish this from this. I want to use the same ion 2 I used before. I have ion 2. Ion 2 is this. And I have ion 3. Look at my arrow. Look at the arrow. I have ion 3. This arrow shows that ion 2 is losing this electron I'm writing here. Have you seen it now? It shows it's losing this electron. And what happened in the oxidation number? The oxidation number increased from +2 to +3. So whenever you see oxidation number being increased, there is loss of electron. There is loss of electron. The first concept we defined was loss of electron, but that loss of electron will always occur simultaneously along with increase in oxidation number. When there is increase in oxidation number, there is loss of electron. Now, let's take another example. Let's move aluminium 3+ to ordinary aluminium. Watch this. Okay, let me do it the other way around so that you understand it. Let me use, this is copper moving to copper 2. Watch the arrow. Watch the arrow. How do we look at the oxidation number? Oxidation number of copper here without any charge is 0. While the oxidation number of copper here is +2. Is it an increment or decrement? It's an increment. Oxidation number increased from 0 to +2. Now, what happens to the electron? Would the electron be here or here? You introduce the electron to the direction that can balance the equation. Watch this. Look at this. I have copper atom here, neutral. It's a neutral atom. There is no charge. I have copper 2 at my right-hand side. That means the oxidation number moved from 0 to +2. That means there is increase in oxidation number. That is oxidation. But I said where there is oxidation, where there is increase in oxidation number, there is also loss of electron. In fact, both of them move together. Both of them move together. That's why when you are reading some articles or when you are reading some text, they attempt to do what? Differentiate the two, for better understanding. But this cannot occur without the other one. It's just like a topic you call simultaneous equation, when 2 or 3 variables are to be worked out in a mathematics. Look at that, 0 to +2. 0 to +2, how do you balance the equation? You balance the ionic equation by the introduction of electron, as I said earlier on. Electron is one of the fundamental particles of an atom that carries a negative charge. Wherever you introduce it, you are introducing a negative value. You are trying to bring down the value at that direction. So, in course of balancing ionic equation, in terms of redox equation, you are expected to introduce an electron where you have a higher positive number in order to equate it to the other direction. Because every equation has two sides, the reactant side and the product side. Now, watch. Look at what I have on the board there. Watch it. I have copper at my left-hand side having an oxidation number of 0, and I have Cu2+, having that at my right-hand side with oxidation number of what? +2. Where do I have a higher value? I have a higher value at my right-hand side. And that is where I'm going to introduce the electron in order to bring the number down so that it can be equated to the number at my left-hand side. If electron introduces negative value to a number, how many electrons do you think I should introduce to this +2 in order to get 0? Because my left-hand side is having 0. Of course, that is 2 electrons. So I'm going to put +2 electrons. You can see the negative value of the electron. By the time this minus interacts with this plus, I have -2. Everything will sum to what? 0. And that is the 0 here. Can you see it? That in the course of increase in oxidation number, there is loss of electron. Now, watch the direction of that electron. The direction of that electron shows that the species that is actually losing this electron is neutral copper. Watch the arrow. Watch the arrow. This loses the electron. So loss of electron is oxidation, as increase in oxidation number is also what? Oxidation reaction. Finally, on the definition of oxidation, we shall be looking at the definition of oxidation in terms of addition of electronegative elements. Addition of electronegative elements. After then, now we'll look at how to assign oxidation number to element and compound. The rules that govern the what? Oxidation number of element and compound. Before then, let's have the final definition of oxidation. Another direction that can help you to understand what oxidation reaction is a reaction where an electronegative element is added to a substance. You won't understand this if you don't know what an electronegative element is. Who will remind us what an electronegative element is? In case you have forgotten, there are those elements that in the course of chemical reaction or ionization, they tend to do what? Gain electron from other elements in order to attain duplet or octet state of stability. Yes, you are aware that some elements in chemistry find it difficult to undergo chemical reaction simply because their outermost shell electrons are complete. Take for instance helium, neon, and argon. Hardly do you see these elements found in a combined state. They are always in a free state. Why? Because they feel they are satisfied chemically. Because they feel that they have attained that level which other elements are looking for. Now, for other elements that have not attained this level, that are still looking for a way to complete their outermost shell, what do? They gain electron. The act or the process of gaining this electron is called electronegativity. So what do we call such elements? Such elements are called electronegative elements. Okay, take for instance chlorine. You can agree with me that chlorine has atomic number 17. Let's have the electronic configuration using the K-LMN shell. The K takes 2, the other one takes how many? 8, and the last takes what? 7. Chlorine is actually looking for 1 electron to reach octet state. Let me demonstrate it here a bit before we finalize on that definition. I am talking about chlorine, which is atomic number 17. In the shells, which KLMN, the first shell takes 2, second one takes how many? 8, the last takes what? 7. The M is supposed to take 8 in order to attain the octet level, but it needs 1 more electron to do that. And how will it do that? It will gain electron from any element it's reacting with. So it is an electronegative element. Electronegative elements are therefore defined as those elements that in the course of their reaction, they gain electron. They gain electron. I hope that is clear. You have understood what an electronegative element is. Give me another example of electronegative element before I can involve it in equation which indicates an oxidation reaction. Okay, oxygen. Oxygen is an electronegative element. How? Oxygen is of atomic number 8. Let's distribute it. Oxygen atomic number 8. That is 2, 6. Watch that element. That element is going to look for 2 electrons in order to attain what? Octet state of stability. In that case, it's an electronegative element. The simple way you will understand those elements that are actually electronegative are those elements that their last shell contain more than 4 electrons. Those elements that their last shell contain the outermost shell have more than 4 electrons. They have the capacity more to do what? Gain electron than to lose their outermost shell. Yes. Why those that have less than 4 electrons at the outermost shell tend to do what? Lose that, so that the next shell electron can be complete. So always remember that an electronegative element will have more than 4 electrons at the last shell. That shows an electronegative element. So in the course of reacting, it will do what? Gain. Okay, imagine an element that has 7 electrons at the outermost shell. That element will either lose that 7 or gain just 1 because it's looking for a way to make the outermost shell to become 8 electrons. That is where the word octet connects. The word octet, 8. The last shell trying to become 8. Now, the element is having 7. It's having 7. Either the element loses this 7 or it gains 1. So which one do you think will be easier? Very easy for the element is to do what? Gain 1. Because whether the element is gaining or losing, there must be energy utilization. So every element is looking for a way to utilize or make use of or spend little amount of energy. So this will do what? Or gain 1 electron. In a nutshell, I'm trying to remind you what you know before. Right from grade 10, or even from your lower checkpoint, you were told that electronegative elements are those elements that get electron when they want to undergo chemical reaction. Okay, having understood this, I want to take you back to the concept of oxidation. Remember, I told you that oxidation is a reaction involving addition of electronegative elements. Addition of electronegative elements. Addition of electronegative elements. Let's react sodium plus chlorine, and that gives us what? Sodium what? Chloride. Sodium chloride. Look at that reaction. Let's balance it first. Very important. I have 2 here and I have 2 here. Watch that. Between sodium and chlorine, which one is electronegative element? We just made use of chlorine as an example of electronegative element. Now, imagine a reaction started from sodium and landed in what? Sodium chloride. What happened? Where the reaction started from, it started here, starts here, and it ends here. Tell me what your observation is. Talk to me. The reaction started where you have just an element, sodium. At the end of that reaction, you are now having sodium plus another element. What exactly is the other element? Chlorine. What is chlorine? Electronegative element or electropositive element? Electronegative element. So we are telling you now that what has actually taken place from here to here is oxidation reaction. Oxidation reaction. What happened? There is addition of what? Electronegative element, which is what? Chlorine. Which is what? Chlorine. Can you see? Little knowledge you have before about oxidation is not enough. I have given you a total of 4 to 5 definitions, 4 to 5 ways you can point at a particular equation that oxidation is actually taking place here. Before I define reduction reaction, taking the different examples I have taken before, I want to remind us, summarize these basic 4 to 5 ways of defining oxidation. Number 1, I said is a reaction involving loss of electron. And where there is loss of electron, there is what? Increase in oxidation number. So invariably, I have summarized the two at the same time. Where oxidation number is increasing, imagine where ion 2 is moving to ion 3. There is increase in oxidation number. And once it is happening simultaneously at the same time, you will find that where the arrow is pointing at, you will see an electron there. Meaning that the species that actually that you can write before that arrow is the one releasing that electron. That means loss of electron. Okay? After that, we discuss issue of a reaction where oxygen is involved, where oxygen is added, where oxygen is added, where oxygen is added, where oxygen is added. This addition of oxygen can come through combustion, reaction, like as I said before, magnesium rebound. Yeah, I was trying to summarize the oxidation reaction, and I was talking about a reaction involving addition of oxygen that took place. The second one. Then the third one is a reaction involving removal of hydrogen. And then lastly, a reaction where there is addition of electronegative element. All I have defined so far, opposite of all of them, explain reduction reaction. Explain reduction reaction. So I'm going to take the 4 to 5 definition of oxidation and turn it the other way around so that we can explain reduction reaction. I'm taking the first one again. The first one, we said increase in oxidation number. Now, for reduction, let's talk about reduction there. For reduction reaction, the first one is loss. The first one on oxidation is loss of electron, while in reduction, the first one is gain of electron, gain of electron, gain of electron. Look at this. This one moving from ion 3 to ion 2. What happened? What happened? For me to balance this, I will introduce electron here. You can see it now. Gain, I'm adding electron plus how many electron? 1 electron. So that if I solve this mathematics, plus 3 minus 1, I will obtain plus 2, which is equal to the 2 here. So what happened during this gain of electron? There is increase in oxidation number. There is what? Decrease in oxidation number. Remember, oxidation is what? Increase in oxidation number, where reduction is what? Decrease in oxidation number. Decrease in oxidation number. So 2 of them have been actually explained here. Increase in oxidation number is oxidation. Decrease in oxidation number is reduction. Loss of electron is oxidation, while gain of electron is reduction. Now, the third one now will become the removal of oxygen. Do not forget that we define oxidation as addition of oxygen. Reduction is now opposite. Reduction is removal of oxygen. Watch, I have copper 2 oxide reacting with hydrogen to give me water plus copper. Look at it. So from here, a reaction started here and ended here. What happened? The original substance contains oxygen. At the end, there is no oxygen in that copper. That means there is removal of oxygen. Removal. There is removal of oxygen. There is removal of oxygen. That is what? Reduction what? Reaction. That is what? Reduction reaction. Okay. Finally is addition of what? Electropositive elements. Addition of electropositive elements. What do we define oxidation to be? Is addition of electronegative elements. So for reduction, it's going to be addition of electropositive. So if I have sodium plus chlorine and I have sodium chloride, I have sodium chloride. Watch that reaction. A reaction starts from chlorine and they land in sodium chloride. Where did the reaction start from? It started where you have chlorine. At the end of the reaction, another substance apart from chlorine was added, which is sodium. Where do you classify sodium to be? Electropositive or electronegative? Electropositive. Electropositive. Why? It has the ability to do what? To lose its atom shell electron. While electronegative element, as I explained earlier on, has the ability to do what? Gain electron. So here there is what? Addition of what? Electropositive what? Element. Now, that will take us to give you a better definition of the topic we are dealing today called redox reaction. Redox. When I started, I wrote something, I say redox, R-E-D-O-X, and I divided it into 2. I said R-E-D means reduction, Y-O-X means oxidation, but both of them are together. Both of them are together. So any equation where oxidation and reduction are taking place at the same time, a reaction or equation showing oxidation and reduction taking place simultaneously, the same time, such reaction is called redox reaction. Such reaction is called what? Redox reaction. Look at that. Look at that. Look at copper 2 oxide reacting with hydrogen to give us water and copper. Oxidation took place from oxidation reaction took place from hydrogen to water because there is what? Addition of oxygen. Addition of oxygen. While reduction reaction took place from copper 2 oxide to copper because there is what? Removal of what? Oxygen. In the same equation. In the same equation. So what happened? That shows that that equation is a redox equation. And the reaction taking place in that equation is a redox reaction. Most example will ask you, why is this equation referred as redox equation? If you watch the equation very well, you will see that reduction is taking place there and oxidation is actually taking place there at the same time. At the same time. Okay? At this point, I want to believe that you can explain vividly, you can explain very well what a redox reaction means. A redox reaction is a reaction where oxidation and the reduction are taking place at the same time. And trying to define the reduction and oxidation, I want to also believe that you can be able to explain oxidation and reduction using the 4 to 5 parameters I have explained to you. In our next class, we shall look at how to calculate oxidation number and how we can assign oxidation number to elements in their various compounds, and then move further to balance redox equation. Thank you. Till then.